This is Sprint 3 for Centipede. I'll start by showing you the game and how it works. Well, you know it works, but I spawn it at low position and a high speed just so I can get through this. As you can see, it touches the edges, it turns, it hits mushrooms, it turns, and then when it gets to the bottom, it'll then turn around. When it gets to the bottom, it's not perfect, but for now, I think it works well enough. That was an edge case. As you saw, he went through the mushroom. So I'll take you straight to the code. My initial code of it before yesterday's class, Tuesday, was using what was essentially an interface or a pure virtual class where each direction that I wanted to make would inherit from this direction state, and they would have to move in a direction, they would have to get the next state, and then get the direction enum. I do have like another project that was about 90% of what the finite state machine, or that is about 90% done, and it's implementing the finite state machine you talked about yesterday. I wasn't able to get it done for this project, so but it works. So I thought I would just stick it or show you this because it works, and then know that I'm moving the code over right now. It's just proving to be a pain. Um, and then I'll take you to the directions. So each direction handles its own, essentially all of the code necessary for that direction. We move, and then if it's about half the size of a sprite, so this is just a rough estimate, um, we will then ask the centipede to check the grid ahead, and then the centipede handles what happens, or it'll change state if the grid ahead proves to be a mushroom or outside of bounds and such. Right now I'm using enums to determine what direction we're going in. That's due to the fact that the centipede direction state, you can't get the specific um, child class that the centipede has right now, just due to the way inheritance works. So I have each one be able to return its own direction, and then initialize itself. The centipede initializes when it's going to be used. Um, and then this isn't used right now. This was when I tried to get fancy, but I wasn't able to. Uh, and then obviously when you're going left, you want to know whether you were going up or down beforehand. So I store whether it was going up or down before, and then go and continue in that direction. Um, and then the last thing is essentially when you initialize it, when you're going left, only in the left or right, you make sure you get the center of the Y position, because sometimes in this check statement, I would go maybe 1 or 2 pixels less or more, and I would end up kind of in an entirely different grid um, than I needed to be. So I make sure it's always centered in the Y position, the sprite is. Um, Centipede movement is just all the includes, and the centipede head implements it through um, an array, so you don't always have to create it. And then this is, you would initialize it when you want to use the specific one. You check the, I realize it's an ugly if statement, but for now it works. You check the bounds, and if it's a mushroom, get the current movement direction, and then for the update statement, we would move in the direction necessary. So we would get the state, which is this guy, and then set the position where we moved, and then change the animation when we get to the animation counter. There's plenty more I could show. I actually have a 5-minute video before this, but I wanted to keep it quick. So that is Sprint 3.